Section 2.2, Solving Problems. When solving word problems, try and follow the 5 steps below. Word problems are challenging, but if you can kind of plan a strategy, try and execute it, then hopefully it'll lead you down the right road. So first thing is read the problem. You might have to read it a few times, but read it a few times to make sure you get what's going on. Next thing is to plan a strategy. It might be a formula you need to know, or it might be a straight translation. Next thing is execute the plan, which means try what you have planned, see if it works. Then answer the question. Once you answer the question, make sure that your answer makes sense. So check the answer, not just to make sure it's correct, but that it actually makes sense with what the question is asking. So number 1, 13 is equal to 3 less than 4 times a number. What is the number? Well, we'll call that number x. So this is a straight translation problem. We have 13, so we know that's the number 13 is equal to. There's our equal sign. The next part is what we have to be careful with. 3 less than 4 times a number. Whenever you see the word less than, the order has to flip, which means whatever comes after the less than goes first. So 4 times a number, so 4x, and then 3 less than that, so minus 3. Now that we have the equation set up, we can go ahead and solve. To do so, we add the 3 over to the other side to get variables on one side and numbers on the other. So we get 16 equals 4x. Last step is to get the variable having a coefficient of 1, so we will divide both sides by 4, and x equals 4. We can check this into our equation, and we will see that it does work. Number 2, 6 minus 3 times the difference of a number and 5 is equal to 4 times the number. What is the number? Alright, so again, this is another straight translation. Let's start by going left to right. 6 minus. So there's your 6 minus. The next part is a little bit more challenging. 3 times, so that we know that means to multiply. The difference, that means to subtract. What are we subtracting? A number and 5. So we need to do 3 times, let's use parentheses to show times, the difference of a number and 5. Difference means to subtract, so the number will be x, and we need to subtract 5. Is equal to, there's your equal sign, and what is it equal to? 4 times the number. So 4 times the number would be 4x. Then we need to find the number. So what do we do to start off? We start off by distributing. We have 6, negative 3 times x is a negative 3x, so minus 3x. A negative times a negative is a positive, so plus 15 is going to equal 4x. We need to combine like terms that are on the same side. We have a 6 and a 15, which gives me a 21 minus 3x equals 4x. Then we'll get variables on one side and numbers on the other. So we'll add 3x over to the other side. When we do so, we get 21 equals 7x. We'll divide both sides by 7 to get the variable having a coefficient of 1, and we end up with x equaling 3. The coldest spot on Earth was found in Antarctica at negative 89 degrees Celsius. UC equaling 5/9, parentheses F minus 32, to convert this temperature to degrees Fahrenheit. Since we know that negative 89 is for the Celsius, we'll need to plug negative 89 in for C. So negative 89 degrees is going to equal 5/9, parentheses F minus 32. So there are a couple ways to continue with this problem. I'll go ahead and just distribute. When we multiply fractions, we should love multiplying fractions because we just multiply straight across. So negative 89 equals 5 times f is 5f, and 9 times 1 is 9. Minus 32 times f is 160, and 1 times 9 is 9. We can get rid of fractions by multiplying everything by 9, and that'll help us with canceling out the fractions. So 9 times negative 89 is negative 801. On the other side, when we multiply by 9 but divide by 9, we just end up with a 5f. And the same thing when we multiply 160 by 9 but divide by 9, we end up with 160. So then at that point, we're going to get variables on one side and numbers on the other. So we'll need to add 160 over to the other side. So we'll end up with 5f, which turns out to be a negative 641, equaling 5f. Divide both sides by 5 to get the variable having a coefficient of 1, and we'll see that the degree in Fahrenheit would have been negative 128.2 degrees Fahrenheit. Number 4. A clothing store has a special sale with every item discounted 40%. If the price of a dress after the discount is $24.50, what was the original price? So we're working backwards. We're not starting with the original price, giving the discount and wanting to know the sale price. We're giving the sale price and want to work backwards. So it's a lot different than just taking 40% of a number. So we need to start off by writing an equation. And one of the things we should know is that the original price minus a discount should always equal the sale price. We do not know the original price, so we're going to call that x. So always label your variables. X is the original price. Then we have to subtract off the discount. Well, the discount is 40% of what though? Of the original price. So we have to take 40%, so make it into decimal, 0.40, times x. To find the discount, you take the percent times the original price. And we'll equal that to the sale price. The sale price was $24.50, so 24.50. So that's how we should set up these problems. Now, if you look on the left-hand side, you will see that x minus 0.40x are considered like terms. There's a 1 in front of the x. So 1 minus 0.40 is 0.60. We still have the x, equaling 24.50. Then we'll need to divide both sides by 0.6 to get the variable having a coefficient of 1. And when we divide 24.5 divided by 0.6, we get $40.83. So we end up with $40.83. Now again, what does that mean? That means that the original price was $40.83. Make sure when it's not just a number, you actually explain what you have found. The next problem will be set up about the same way, just with some little bit different wording. A report shows that revenue for 1 month was $24,360, which is a decrease of 12.5% from the previous month. What was the previous month's revenue? So again, this is going to be our x. X will equal the previous month's revenue. So we'll start with the previous month's revenue, and we're going to have to subtract off 12.5%. Changing that into decimal, we get 0.125 of what though? Of the previous month's revenue. And what's that supposed to equal? The new revenue, which is $24,360. So again, on the left-hand side, we're going to combine like terms. There's a 1 in front of that, so we're going to have 1 minus 0.125x. Figure out what that is. I'll let you go ahead and do the math on that one. When you divide, you're going to end up with x equaling 27,840. 27,840. So see if you can finish that one on your own. Again, what did x represent? The previous month's revenue. So the previous month's revenue, I'll abbreviate revenue, is $27,840. Number 6. Two cars are traveling toward each other on the same highway. One car is traveling at 65 miles per hour and the other at 60 miles per hour. If the two cars are 200 miles apart, how long will it be until they meet? Again, it's not a straight translation. We do need to know a formula. So how are distance, rate, and time all related? Well, distance equals rate times time. So let's see what's happening here. Here's my beautiful car. Sorry, I am not an artist. And we have two cars on the same highway traveling towards each other. So we'll put another car over on this side. And they're traveling towards each other. So one car is going that direction and one car is going the other direction. And we're going to see how long will it take till they meet. Now, what do we know about the blue car? Well, the blue car says the distance equals the rate times the time. Let's say its rate will be the first one, so 65 miles per hour. And then the time it's going to be taken, we don't know, so we'll call it t. For the green car, we have its distance is also going to equal a rate times a time. We'll take its rate of 60, and the time's going to be the same. The great thing about this problem is that they left at the same time, they're going to meet at the same time. The only thing that's going to be different is the blue car is going to travel a little bit farther than the green car. Why is that? Because it's going faster. Now the one piece of information we haven't used yet is that they were 200 miles apart. So this whole distance is 200 miles. So hopefully you can see that if we take the distance of the blue car and we add the distance of the green car, that's supposed to equal the total distance they were apart, which is 200. So 65t plus 60t is going to equal 125t, and that's supposed to equal 200. Then all we need to do is divide by 125, and that will give us the time. So the time's going to be 1.6, t equals 1.6. Again, what does that mean? It will take 1.6 hours for them to meet.